what we're going to be going over here is a learning curve here, and we're going to be looking at the incremental time model, or what they refer to as the Crawford's model, and we're going to apply it to an actual problem that we're going to be looking at here. So when we talk about these learning curves here, when we initially have a new product or a new production operation, we have a certain amount of time that's going to be involved in manufacturing that product. So for our first units, we're not very experienced, so we're going to have a certain amount of time here. But as we gain experience, our time on a per unit basis here is going to decrease here, because we're going to have more experience. We're going to be able to manufacture that product in less time here, and we're going to save money by doing that here. We're going to have a higher cost here when we initially start producing the product, and as we produce more and more of the product, we're going to have this learning curve, as they call it here, and we're going to be able to reduce our cost by this learning curve. So what we're going to be looking at is a specific problem here, where we're going to have a certain number of units that we have produced up to a point. In this case, it's going to be 2 units that we've produced up to a certain point, and we want to know what the additional 4 units would. We're going to produce an additional 4 units here. So we're going to have 2 units that we have already produced, and we're going to work our way up to 6 units. And based on our learning curve here, we will have to determine our different costs. So we're going to start with our equations here, and then we're going to come back to these graphs to get an understanding of what we're talking about. Okay, so here we sit. We're going to go through our equations here. And again, we're going to be using this incremental unit time learning model, or this learning curve, and that's really the Crawford's model here. So this is what we're going to do here. This is going to be a problem here. Let's assume we've produced 2 units here. So the question is, how much will it cost to produce 4 additional units based on our learning curve here? So with this Crawford's model, or this incremental unit time model, our function is this here. Y, that's our incremental unit time for the lot midpoint of the unit that we're looking at. This is a lot, or a number of products, a certain grouping of products that we're making, and it's a midpoint here. It's a midpoint. So Y here equals A. A is the time or cost to produce the first unit. And then A times K. The K is the algebraic midpoint of the lot that we'll be looking at. That's the group of products, or the number of number that we're making here for this production run here. So, okay, K is the big item here when you're talking about this incremental unit time learning model here. And then this K is raised to the exponent here of B. Well, B, for these learning curves here, it's really the log of the learning rate divided by the log of base 2 here. Okay, so maybe let's go and let's determine what our B exponent is here. Okay, so for our problem, we're going to be working with a learning rate of 80% here. It's going to be a 20% improvement rate, but it's an 80% learning rate. So when we're working with that learning curve here, that learning rate of 80%, determine our B exponent, all we do is we take the log of 0.80, or the 80%. It's 0.80 here, divided by the log here of base 2, or 2.0 here. So that in itself is going to give us that B exponent here for that learning rate of 80% is going to be a negative 0.3219 here. Now, we're further going to look at subtracting this B exponent here, this learning rate exponent, from the unit of 1 here, and that's going to give us 0.678 here. We're going to use that later on in our problem here. But what we have to be concerned with is this negative 0.3219 here for B. Okay, so there's our learning rate. Okay, so what we have to do, we've got our we got our function here. And the other thing, just expand on this function. If we take X is going to be the lot size that we're going to be looking at. We take that times Y, our incremental unit time here. And that's going to give us our total time here. And then it's just taking X times both sides of the equation here. So we'd have X times A, our time of cost of our first cost to produce our first unit here, times K, that algebraic midpoint, raised to our exponent B here. Okay, so but nonetheless, we have to take X times both sides here to determine our total cost here. This is for the unit cost here, and this is going to be taking X time as our total cost here. Okay, so what we have to do is we have to expand on this here. So what we have to do here is we're going to deal with this K This is the key here with this algebraic midpoint of the lot, and it becomes a sort of a complicated little formula here to work with here. But nonetheless, we have to understand what this is. So K equals, and let's just go through it. L here is the number of units in the lot here. Now, let's just understand what that is. Our number of units in the lot is actually 4. We're going to need 4 more units here. We're going to produce 2, but we're going to need 4 more, so that's going to be our lot size here, 4 units here. Okay, so that's our L function here. That's going to be 4 units here. Now, we take that times 1 plus b here. And remember, b was our exponent here based on our learning rate here. Now 1 plus b was that negative component here. That's why we had to subtract that from a unit of 1. So that's going to be 0.678 here. Now, we take and we divide that entire amount here by n2 raised to 1 to the b here. And well, let's understand what n2 is here. That's the last unit that we're producing here in this lot. And what we do, n2 equals the last unit plus 1/2 here. Okay, so let's go and calculate that here. So n2, I'm showing it as ne here, that would be 6 units here. That would be our 6th unit of the last unit here is number 6. We started with 2, so we're moving up here by 4 units, so we're having n2 would be our n2 here, that last unit is 6. So that's really taking our ne here is 6. We take 6 and we add 1/2 to it. So we're going to come up with our n2, or that last unit was going to be represented by 6.5 here. Okay, so that's our equation here. Now we raise it to 1 plus b. Now remember that b was that negative point, so we come up with that 0.678 again here. And then we subtract from it n1 raised to 1 plus our b here exponent. And let's understand what n1 here is. That's the first unit minus 1/2 here. So just looking at our equation here, that first one was, it would be number 3, unit number 3 here. We had 2 produced, so the first unit is going to be number 3 here. Okay, so number 3, there we have to subtract 1/2 from number 3 for our n1 here, for our first unit minus 1/2 here. That represents 2.5 here. Okay, so we've got that taken care of, and then raise it to 1 plus b, which is that 0.678. And then that whole quantity is raised to a minus 1 here, divided by our b here, which is a minus, what was that? It would be a minus 0.3219, which is actually the minuses cancel out, so you just got 1 over 0.322 here. That whole amount in here raised to that power here. So just solving, you can see the arithmetic here. We just solved it out here. And what we're going to come up with here is k is going to equal to 4.2938 here. So that's our function that's our k value. That's that midpoint. That's algebraic midpoint of the lot here. We're building from what, 3, 4, 5, 6 units, but this is the algebraic midpoint here, 4.2938. We could think of it as, what was it? We'd have like 3, 4, and then 5 and 6. So it's a little over 4 here. The midpoint is, you might think of it's like 4.5 or something like that, but it's a little less here because this is that special function that we had, a special value we have to deal with when we're talking about the incremental unit time here. So we have to go through all that arithmetic here. So let's just go through and let's figure out our time and hours of the midpoint of this unit, because that's what we're working with direct labor hours. We're just saying everything that our costing here is based on direct labor hours, this function y here. Okay, so we just put everything in here. So for y, let's just say that first unit is costing us 100 hours here. First unit to build, we have 100 hours. So a equals 100. And then we take that times our k amount here. Our k amount was at 4.2398. And then we raise it to the power of b. And b was, what, just based on our learning rate alone here, minus 3.22. So that we raise that to the power, this value here to that power here, and we're going to come up with 62.56 hours. So that's y. That's our incremental unit time for the midpoint unit that we're building, the midpoint unit of those 4 units. Okay, so there it is, 62.56. So our total time, we just take x. That was x to the lot size. We're just saying is 4 because we're building 3, 4, 5, and 6 units for a total of 4 units here. Take it times y, our function here. well, just take x times both sides here. So you're going to come up with our total time for the lot's going to be 4 times our total hours here, 62.56 hours for 250 hours here. Okay, so we worked through our problem here just through our equations and went through it solving it, the arithmetic here for our problem. And if we're just looking at these 250 hours, if we look at it you want to determine in terms of dollar amount, just say our direct labor plus our overhead we have assigned here at $50 per hour. So we got 250 hours here direct labor times $50 per hour. So we'd have a cost here of $12,500. So that is the cost here, what we're talking, that lot size of 4 here. So that was the cost to build those 4 additional units. We had 2 units already, so we're building units 3, units 4, units 5, and unit 6. So that's using this incremental unit time learning model. Okay, so that's our arithmetic here. So let's go up and let's look at it on our graph here. Okay, so we're going to start out with our incremental time model here, this Crawford's model, and we're going to look at it in terms of our total hours here. And that was that x times y function here, where we started out with our initial cost here was 100 hours, our 100 direct labor hours here to build our first product. But as we gained experience up the line here, we reduce, we have lesser time on a per unit basis or per quantity basis here. We're starting out with this graph here. So if we look at it in terms of our graph here, our x, our number of units produced here along our x-axis, and then our total time. Those are our total hours here that we're dealing with. So we started with this third unit here, and we have to calculate our cost here up to our 6th unit. So we're working from the 3rd unit here to our 6th unit here. So what we're going to start with here, our 2nd unit, if we do our arithmetic here, and we'll look at it on those numbers, our 2nd unit here was 180 hours. Took 180 hours here for a 2nd unit. First unit was 100 hours using this incremental time. The function we have here, y equals the first unit here times that power, or our k, our algebraic midpoint a lot, raised to b here, the exponent, our learning curve exponent here. That would give us 180 hours here at the 2nd unit. And then the 6th unit, if we put that in here, it would have been 430 hours. Just pump it into that function here. So really what we're just looking at is this total cost from the 3rd unit, or actually from the 2nd unit up through the 6th unit, but that would be unit 3, 4, 5, and 6 here. So what we're going to do just to prove out that our arithmetic was correct when we went through our equations, for 430 hours here for our 6th unit, our 2nd unit here was 180 hours, so just the difference. All we're looking at is the difference on this curve here, and those are the 250 hours. And you can see that. Those were that lot size of 4 here, from 3, 4, 5, and 6 here, times those were that midpoint, total time for our midpoint unit was at 62.56 that we calculated in our equation, and that's 250 hours. So you can see on our curve here, using this function here, we would have developed this curve here, and then based on that, you're just looking at the cost between those 2 different points that we're dealing with here. So our arithmetic using our equations, it works out here with our graph here. And then okay, just so you understand this graph here, this red line, this is the one this is that 80% learning rate curve here. I've got also a 90% learning rate curve here shown in green. We're dealing with the 80% one here. And I've got different hours here. I've got, you can see at 16 hours we're up to 892 here. Okay, but what this is here, in this case the red one, that's cumulative total labor hours that we're looking at. So we got our number of units here, total labor hours here, and that I have x times that y midpoint here. Okay, so let's go over here and let's just look at our arithmetic here. Okay, what I've done here, had we used that function here, we would have come that sum of y here we started out with, and here I got the x, the output of the x units here, and we're dealing with that 2nd unit here to the 6th unit here, that lot of 4 here of 250 hours here. So if we went, and all we're doing along that line, we're just summing. We're summing that what it costs for the 1st unit, and then add to it what it costs for the 2nd unit here, and we got that 20% learning rate, so you got a 20% discount every time you double your production, you go down by 20%. Okay, so that's really what that 20%, the learning improvement rate is. So then the next unit here, unit 2, we gone, just putting it into the equation, we come up with 3 here for 250, and then we on 2 until we get up to unit 6 here. We got, I said it was 430, it's 429 if we put it in there. Okay, so that's what we're looking at, that units 3 through 6 here. You do your arithmetic, and you're going to come up with 250 hours here. And then your unit time, that midpoint, it kind of sits in here. So for our unit time here, for 2 units, we had it 80 hours here, or 80. And then because we got that learning curve, we're improving everything, it's moving down here. And at the unit 6, we're actually at 56.17 hours. But with this midpoint, because we have to use it for that incremental unit time here, that K value, it's sitting at 62.56. So you can see here the unit number 4 would have taken just 4 units with 64 hours here, and the 5th unit is 59.56. So this is our midpoint. That was that weighted average, or whatever that algebraic midpoint of the lot here, just to understand what's going on. Okay, so this fits into our curve over here. Okay, so that's our total time here, and this is the incremental time model, the Crawford's model. Now let's go down here and just look at one other thing here. So now on this curve here, this is just the unit time. We could go just off this unit time. We didn't have to go through that big equation there where we used the K value here. We could have just used the equation here. Well, y equals A, that's the cost of the first unit, times x. And x is the number of units produced here, raised to the power of b here, or that b exponent for our learning curve here. Now, we went through and we were using that k, that incremental unit time midpoint, or that algebraic midpoint lot. We could have just used the x value here. But just to understand that, how that works here. So here's our incremental, our learning curve here. We increased it down here. So we're just looking at the individual unit time here. And we'll go and look at that. So all we're doing is we're following this 80% learning rate here. So we as we increase our production, or we get more experience here, it's taking less and less time on a per unit basis here. This y value is a unit basis here. And again, I got the x number of units produced across the bottom here. So if we just we're just looking at this range here from the units of 3 here to those units of 6, that total of 4 units here. So just looking at that time, had we just gone in, and we'll look at the numbers here, we could just use the x value here based on our x production. We wouldn't have had to go in and recalculate that k value here. Just based on our x value here, all we're looking at, again, is we're just summing along this line. But we have to figure out the value here for each of those points here. So it's pretty easy to do when you just have 4 different units here. You can use that x value. And actually with computers nowadays, it really doesn't matter here. You just plunk it into your computer program and you're going to come up with some value here. So we're just looking at from units 3 to 6 here. And we'll go and look at those numbers here. And what this line is here, those are just the labor hours per unit. The only point I'm making is if we're building thousands of units or whatever, dealing with those, then we would have to increment it, solve this, look at this line in terms of every unit here. We have to sum it along all the units here for each unit here to determine our total time here. So let's just look at our basic equation here. Y equals A, that's the cost of the first unit, times x, whatever units we're working with here, raised to that exponent of b here. That's for our learning curve. So y here for this function here, our first unit was costing 100 hours. That's up here, 100 hours here for the first unit, we're saying. We're just basing it on our direct labor hours, and then it decreases here as we make more units here. So 100, cost of our first unit here, times x, whatever x number we're dealing with here, raised to that exponent here. That was based on our learning rate here. It was that minus 3.22. Okay, so that's how we would get our labor on a per hour basis here. Up above, we looked at the cumulative amount here, and that's where we had to use that K, that K algebraic midpoint here. But if we just look at it based on a per unit basis here, we can use the X amount here. And just to go through here and look at what our values would be here. So looking over here, so let's just say we summed Y here. So starting with that third unit, Y3, we would have had a 70.21 hours here based on that learning curve at 80% learning rate here, 20% improvement rate. And then the fourth unit, Y4, would have been 64 hours here. And then Y5, the fifth unit here, would have been 59.56 hours. And then Y6, that last unit here, we would have produced that in 56.17 hours here. So you just total up these 4 points here on our curve, or there's 4 for each of those units here. Each one of them would have been a less and less amount here because we have that learning rate here. We have that improvement through each of the units here. But if you total them all up, you're going to come up with 250 hours, just like we did with our equation and just like we did with our cumulative total labor hours above in our other graph. So what we're doing here is just the cumulative total time is just the summation of this y here, and that y was based on our x units here, not our k amount here, and we're just doing it for, in this case, at units 3, 4, 5, and 6, x3 through x6. So y here is just the individual unit time here. Okay, so you can see what we've done here. We can solve this problem here. We did it through the equations, and then we looked at it in terms of our graph up above here was like cumulative total hours here. And then those cumulative total hours required that special, we had, instead of using this x value here, y equals that x value, we had to use y equals a, the cost of the first unit, times k. And that k was that algebraic midpoint of the lot here, and raised to the power of b. But nonetheless, the proper way to do it is with the k value, and we did it through the equations and we did it up above. I'm just showing it here on a per unit basis what we were doing here. We were just looking at this, summing for each of these units along this timeline here on a unit basis and down here. And we did the same thing on our graph up above for our total time here and for our equations. But just to understand what's going on, that's why we looked at it based on individual unit time. Okay, so that'll summarize our discussion here, and we applied this incremental time model or the Crawford's model here to an actual problem that we had to solve here. And we had a certain number of units that we started with here. We already had that learning curve up to that second unit here. So we were sitting at 100 here, and then up to our second unit we went down to, well, it was from 100 here for our first unit, we went down to 80 hours here for our second unit. And then for our successive ones here, let's look at it. For our third unit would have been 70.2 hours here. And the fourth unit would have been 64 hours here. And then the fifth unit was 59. And then that sixth unit would have been like 56 hours here. And we did it, in that case, we used this equation here based on x, our number of units produced here, raised to the learning rate exponent here of b. Okay, so that'll summarize our discussion here, looking at this incremental time model or the Crawford's model and applying it to a particular problem.